We're looking at composition of functions today. So we're continuing on with function notation, operations on functions, and then looking at what a composition means. So we have some new notation to look at. The notation basically has two sets of brackets. So inside the big set with f is another function. So that basically means that if you think of order of operations almost, you're replacing the x in f with whatever g of x is. And that means f is composed of g of x. And so that's why it's a composition of functions. Okay, so let's see how this works with this example. So we're going to discover some properties here. So we're given f and g. It says determine g of negative 2. So pretty basic question. G of negative 2 equals 3 times negative 2 minus 1 is negative 7. Okay. Then it says use your answer to determine f of g of negative 2. So that means now negative 7 is going in here because that's what g of negative 2 is equal to. So this will be f of negative 7. And so now we put in negative 7 everywhere in f that there was an x. So really, this is negative 7. We're replacing it everywhere there. Okay, and then evaluate that according to order of operations. So what's that? 49 plus 14 plus 3 is 53, 63, 66. Okay. Next one, now we're going to find f of g of x. So no numbers. So g of x is, what was that? G of x is 3x minus 1. So I'm going to put this underneath actually. So this equals f of 3x minus 1. So then we substitute this whole thing in for every x in f. So 3x minus 1 squared minus 2 times 3x minus 1 plus 3. So really, we replaced every x in f with 3x minus 1. So just be careful. Make sure you square this correctly. Expand this out correctly, and then collect like terms correctly. Okay, and then from that answer, okay, from C, find f of g of negative 2. So that means we've already found f of g of x, so now we replace every x here with negative 2. So this is going to equal 9 times negative 2 squared minus 12 times negative 2 plus 6. So 9 times 4 plus 24 plus 6 is 66. Okay, how did your answers compare? They were the same. Okay, so to summarize this, f of g of x is the composition of the functions f and g and is formed by substituting g of x for x in the equation of f of x. Okay, so this here, brackets for f, now we've replaced that original x with g of x. The function is read as f of g of x. Or you might see it as f at g at x. So at instead of, but means the same thing. Another notation is this, okay? Few less brackets, and it's an open circle there, okay? So sometimes people abbreviate it with fog because it looks kind of like an O. But it's an open circle, and it means composition of functions. So that's the same as f with the brackets, g of x. And so order matters here. This is your inside function. So f, the first function, is composed of the second. Then if we switch them around, g of f of x, then it would be g first, open circle f. And that's formed by substituting f of x for x into the equation of g of x. Okay, so as I talked about yesterday, these are different. This means multiplication, this means composition. Okay, so just be careful on that. Okay, so we're going to look at some discrete functions here. So a table of values shows various values of x along with corresponding values of f of x and g of x. Complete the table by stating the composition. So this is just to make it a little bit easier. You could show this as ordered pairs if you wanted. So for example, f would be -2, 3, 0, 1, 3, 5, 4, 0, 5, -2, and g would be -2, 0, 0, 4, 3, 6, 4, 3, and 5, 1. Okay, that's really what that's meaning. So now if we're finding f of g of x, so this x here, we're going to do it for each x value in the chart. So that means we want to find f, and I sometimes convert it back to the bracket forms. So f of g of -2. So g of -2 is 0. Okay, so I have to do this part first. So g of -2, or you could look here. When x is -2, what do I get for y? 0. So that's going to go in now for my f. So x is 0 in f. That means y is 1. Or you look at the chart. When x is 0 here, y is 1. So you don't need to write out the set like I did, but sometimes it might make it easier. So then the next one, this will be f of g of 0. So when x is 0, g is 4. So this is going to be f of 4. So now I want to look at when x is 4 and find f. That's going to be 0. Okay. Or you can look at, okay, g of 0 here. So the y value is 4. So f of 4, y value 0. Then here g of 3 is 6. So then f of 6, there isn't one. So it does not exist. Then g of 4 is 3. So then f of 3, we look at the value there, that's 5. Then g of 5 is 1. And then we look for f of 1, but there isn't one. So that does not exist. Okay? And then we'll do the opposite of that. So g of f of x. So now we're finding g of f of -2. So f of -2 is 3. So g of 3 is 6. Then f of 0 is 1. So g of 1 doesn't exist. There's no x value of 1. Then f of 3 is 5. G of 5 is 1. F of 4 is 0. G of 0 is 4. And then f of 5 is -2. G of -2 is 0. Okay? So that's with the discrete functions. And then we'll do it with graphs. I'm just going to minimize this a little bit. Maybe a little bit more. Okay. So it says use the graphs to evaluate each of the following. So we need to find g of -1. So g is the line. So when you look at when x is -1, what's y on the function for g? It's 5. So this is going to be f of 5. So then we want to look at when x is 5 on the f function, and that's 12. Then g of +1 is 3. So this is going to be f of 3. And then on f, when x is 3, y is 0. Different notation, same thing. It means f of whatever g of 0 is. So when x is 0, on g, I get 4. So when x is 4, on f, I get 5. And then g of f. So here in the right-hand column, f of 4. So on f, when x is 4, y is 5. So this is going to be g of 5. Then I look when x is 5 on g, y is -1. Then when x is 1 on f, I get -4. And then g of -4 is 8. And then f of 0 here, so f of 0 is -3. G of -3 is 7. Okay. Then the next ones, we want to find x when we're given the final value of f of g of x. So we're given that f of g of x equals -3. So you want to think about, okay, let's work backwards. When is the function for f equal to -3? So that is actually in 2 places for f. So that is, so that is when g of x equals 0 and when g of x equals 2. Okay, because there's 2 places where f is equal to -3. So now we have to find the x values that give us a y value of 0 and 2 on g. So y value of 0, okay, gives us x equals 4, and a y value of 2 gives us an x value of 2. So those are your 2 values. Okay. So you're working backwards in these. Next one here, I want to look, first of all, where f of x equals, I want to look where g equals -1, and that's what f of x is going to be equal to. So g, where's on g, when the y value is -1, I get an x value of 5. That means that's what f of x is equal to, because g of 5 is -1. Okay, so that means f of x has to equal 5. So then I look at my graph for f, across here. When is the y value 5? It's 5 at -2 and 4. Okay. Then, same thing here. So when is g equal to 9? So 9 would be here when x is -5. So that means f of x has to equal -5. And when we look at -5 here, there are no values. So this does not exist. So there's no values of x that this occurs for. Okay, so what is the issue with that? There are no values where f of x equals -5. Okay. So just like we did for operations on functions, we looked at the domain. Now we're going to look at the domain for the composition of functions. So what's the domain of g of x? So any polynomial, remember, it's all real numbers. And domain, though, for h of x, it's a radical. So remember, 2x minus 6 has to be greater than or equal to 0. So x has to be greater than or equal to 3. Okay, so let's, again, we're going to look at a little discovery activity here to see what the issue is with domain. So it says determine the simplified exact value of h of g of 4 by different methods. So determine the value of g of 4 and then substituting it in. So g of 4 equals 4 squared minus 1, which is 15. So then h of 15 equals 2 times 15 minus 6 is 30 minus 6 is 24, which is, you can simplify that to root 6. Okay. And then the other method is finding the simplified form of h of g of x. Okay, so h of g of x would be x squared minus 1. Okay, so that's going to be root of 2 times x squared minus 1 minus 6. So 2x squared minus 8. All right. Then finding h of g of 4 means we would substitute the 4 in. So 2 times 4 squared minus 8. So 16 times 2 is 32, minus 8 is 24. So we get the same thing. Okay. So we found h of g of x here. So I'm just going to write that out. H of g of x. Okay, so we know that 2x squared minus 8 has to be greater than or equal to 0 in order to be defined in that function. So that's solving a quadratic inequality. So that's x squared minus 4 greater than or equal to 0. So remember, that would be difference of squares. That would be negative 2 and 2. Or if you graphed it, parabola opening like this. So where is it positive? So in this part and this part. So that says that x has to be less than or equal to negative 2, or x has to be greater than or equal to positive 2. So D. Okay. And then that will be defined. So continuing on. So that's all good that way. Now we want to determine the simplified exact value of g of h of 1. So we're just doing what we've been asked to do, and then we want to look at the domains and see what makes sense. Okay, so simplified form of g of h of x. That's going to be g of, and then h, remember, is 2x minus root 2x minus 6, and then g is x squared minus 1, so that's going to be root 2x minus 6 squared minus 1, so that's 2x minus 6 minus 1, which is 2x minus 7. So suddenly we went from a radical and now it's a linear. Okay, then it says determine the value of h of 1 by substituting the result into g of x. Okay, so h of 1 is going to be root of 2 times 1 minus 6. So here we get root of negative 4. Oh, you know what I forgot to do? Yeah. So root of negative 4 does not exist, but I forgot to finish this off, right? So g of, okay, so we do get a value there of negative 5, but in the second part, we don't. even though we're finding the same thing. We're trying to find g of h of 1. First method was by finding the expression in terms of x and then substituting 1 in. Second method was starting from the inside out, substituting 1 in, and then if we got a result, putting it into g, but we didn't. We got an imaginary number is really what it is. Okay, so why are the results in part D not the same? Because what's the value? 1 is not in the domain of g of h of x. Okay, so the previous one we were doing h of g of x. So now we're doing g of h of x, and we didn't check the domain to start with. Okay, so you do need to do that. I mean, if you start from the inside out for an actual calculation, you're going to be fine because you'll know right away. But if you find the composition in terms of x, you do need to look at the domain. So in part D, you found that g of h of x equals 2x minus 7, but you also found that there's a restriction on the domain. State the domain of g of h of x. Verify with a graphing calculator. So basically what you want to do is take a look at your inside function. So my inside function was root 2x minus 6. So the domain of that, so domain for h of x, x greater than or equal to 3. Okay, and then for the overall function, my domain is all real numbers. Okay, and it's where these overlap. So where do they overlap? For x greater than or equal to 3. Okay, and so then for that last question, we had an x equals 1, which is not in that domain. Get out your calculator and let's graph it. So the biggest thing here, calculator is good for composition of functions if you enter the composition without simplifying it. So here, if we're doing, so if we go back to D, part 1, and just move this over. If we enter just this part here before we simplify anything. So open bracket, square root 2x minus 6 out of the square root, close the bracket, square it, and then minus 1. And let's do this just on a standard screen. You can see that we only see part of it. So 2x minus 7, it looks like a line, 2x minus 7, but our first value is at x equals 3. Okay? So if you enter it like that, before simplifying, the calculator will actually sort of give you the domain. Okay, you can look at it there. But if I had put in the simplified form, obviously I'd get a line that goes on forever. So that's kind of a little hint. If you go back and let's clear that off, let's do the previous one here. Square root of 2x squared, bracket, x squared minus 1, close bracket, minus 6, and then get out of the square root, graph that, and you can see the domain. Okay, and again, so my inside function in this one was g, so that was all real numbers. My outside function was 2x squared minus 8, and then where do they overlap? Obviously at this. This is the restrictions. There's nothing restriction for x. Okay, So that's really what you want to do. Compare the final domain to the inside domain. Okay, so the domain of f of g of x consists of all the values of x in the domain of g, the inside function, for which g of x is in the domain of f. So determine a simplified expression for each of the following. You must take the domain into account when stating the expression. Okay, so when you give your final answer, basically you want to make sure that you state the domain. So g of x was what? G of x was the first one, was it? Just a sec here. Oops. G of x was x squared minus 1. Yeah. So this is going to be g of x squared minus 1, which is x squared minus 1 squared minus 1. So that's the simplified expression. It's a polynomial function. The original domain for g was all real numbers. The overall is all real numbers. So that's your domain overall. Okay, then h of x, so root 2x minus 6. And then that's in here, root 2x minus 6. So really, there's not much you can do here. Can't really simplify anything. It's the root of something that has a root. Your inside function is x greater than or equal to 3. Then to solve this, to find the domain of the final, we know that 2 root 2x minus 6 has to be greater than or equal to 0. So then that's root 2x minus 6 has to be greater than or equal to 3 when we bring the 6 over and divide by 2. And then square both sides, but that changes, we have to think about that when we think about an inequality. So if you do square both sides, is it going to be greater than or equal to 9 here? You just have to check if it's switched. So that would be 2x greater than or equal to 15, so x greater than or equal to 15 over 2. And so 15 over 2 is 15 minus 6 is 9, square rooted is 3. So that works. If it was a negative root, then that's where the issue comes in. So where does that overlap? So we've got x greater than or equal to 3, and then x greater than or equal to 15 over 2. So the overlap is this. So your domain is greater than or equal to 15 over 2. Okay, we've talked about using your calculator. So this is just a different version. If you want to put in both, you can put y1, y2, and then y. It's almost like a function notation, y1 of y2, and it will do it for you. Or you can just enter it like I did. Okay? So the graph for y3 is the graph of y1 composed of y2, and so that was g of h of x. And does it confirm the statement? So we already did for C, so we already did that one here, and we checked that already, so it did confirm that. Yes. And then g of h of x, g of g, h of h to determine the domains for f and g. So we already did this one as well. And then you can do, I'll leave that for you to do, okay, for these ones. All right, so if h of x is f of g of x, state a possible expression for f and for g in this case. So this is our final composition, okay, before anything's been simplified. So what could we state for f and for g? Well, this, if you look at the brackets, if they're the same, then that I'm going to say is my inside function. So I'm going to say g of x is 2x minus 5. And then f of x would be everything that's performing operations on that. So 3 times that g of x, which is now x squared, minus 7x minus 6. Okay, so I always look for brackets that are the same. In a rational, the next one, the denominator, I would make that my inside function. So this I would say, okay, g of x is 2x plus 9. Okay, so that's that part. So that means f of x would be 3 over x minus 10. Because then that just gets replaced. Okay, there's more than one possibility, but these are the most obvious. Okay, 7, if f of x is 2x plus 1 and h of x is 3 minus 2x, determine g of x such that composition is equal to h of x. Okay, so this is your final. Right, so 3 minus 2x equals 2 times something plus 1, right? G of x has to go in here. So we want to think about what this can be in order to get 3 minus 2x. So how about a negative x, right? And then something so that when we add 1 to it, we get 3. So that works. So negative 2x, when I expand this out, I would get negative 2x plus 2 plus 1, which is negative 2x plus 3, which is the same as what we have there. So I'd say g of x is negative x plus 1. How else could you do it? So I just kind of did trial and error. You could go, all right, 3 minus 2x equals 2 times g of x plus 1. So then bring 1 over, that's 2 minus 2x equals 2g of x. Divide by 2, 1 minus x equals g of x. That's a more formal way of doing it. Okay, now we've got some functions here. Determine the composition. Now we've got 3. So f of g of h. So f of g of h. F of g of h. And f of, so g of 4x. That's going to be 4x all squared. And then that's going to be the root of 4x all squared, which is 16x squared, which is equal to 4. Now 4x, but now no matter what x was, it's the absolute value, okay, because it comes out as a positive. So when we think about the restrictions, we're starting with the inside. This is all real numbers, so we'll get anything out. Then we're squaring. This is all real numbers. And so x could be anything here, okay? If we have the absolute value, that's going to be our result. So x is going to be all real numbers in this case, okay? Then f of h of g of x, x squared, is f of 4x squared, and then that's the root of 4x squared, which is going to be 2, and then the absolute value of x. Because we could have here x squared, x could be anything, and we get a positive out, multiplied by 4 is still a positive, so this is going to be a positive. And when we take the square root, we'll get a positive. But x could have been a negative to start. Okay, this is all real numbers as well, because that square root is happening at the end. Then g of f of h is g of f, which is root of 4x, and g is root of 4x all squared, which is going to be 4x. Now in this case, inside x could be anything, but then when we take the square root of that, we can't take the square root of a negative, right? So x has to be, so if we just did this part here and found that domain, x has to be greater than or equal to 0. And then we're squaring it, so it doesn't matter. So here, x is going to have to be greater than or equal to 0. Okay? So it's kind of like doing it in steps, finding the domain of f of h of x, and then using that with your final. So g of h of f of x is root x. G of h is 4 root x. G is 4 root x all squared, which is 16x. Same deal here, x has to be greater than or equal to 0 to start. And when we multiply it by 4, the result has to be, x has to be greater than or equal to 0, so the overlap works. Then at the end, it's all real numbers. Where's the overlap? X greater than or equal to 0. Okay. Then h of f of g of x is x squared. H of f is square root of x squared. And then, so h, square root of x squared is absolute value of x. And then h is multiplying by 4. So that's going to be 4 absolute value of x. Okay, so inside, that's x element of the set of reals. Taking the square root, x can be anything because we're squaring it first. Yeah, so overall that simplifies to x, which is all real, but absolute value, so x can be anything. So that's all real numbers, and then that stays. So overall, all real numbers. Then h of g of f, which is square root of x. H of g is x squared, so that's squared. And then h is multiplying by 4. So, sorry, this is x, and then that's 4x. Okay, so now x has to be greater than or equal to 0 to start. We square it to get x. That's all real numbers. Where did the overlap? Here. And then multiplying by 4 doesn't change anything. So x greater than or equal to 0. You can put it in proper domain notation. I'm not going to spend the time doing that. Okay, then 3 more functions. So now notice this is a multiplication. So this is g of f times f. So that's root x times root x. Well, what's root x times root x? Is x. Okay. And then, and really it's x. X is going to have to be greater than or equal to 0 to start. So you don't need absolute value signs. Because really that's root x squared, which is absolute value of x. But you don't need them because of your original function. Then g of x is just 1 over x. Okay? And then here, we know that x cannot equal 0. So overall, that means x has to be greater than 0. Okay, so you look at your overall and your original, and that's where does it overlap? Would be this. Okay, g of f of x squared, g of root of x squared, which is really absolute value of x, and g is 1 over that. Okay, so x can be anything here. Because we're square rooting it and x was anything but it was squared, it's okay. So that's why we have the absolute value, so that because it's going to come out as a positive. X cannot be 0, so then where those overlap, so again, x is going to be anything except 0. Okay, then the next one, we're adding two functions together. So let's do g plus h of x. So g plus h. Might want to get a common denominator. That's going to be 1 plus x cubed over x. Okay, so then this is f of 1, let's put it in order, x cubed plus 1 over x. And then we're taking the square root. Okay, so this is a little bit harder. We know that x, the inside function here, basically x cannot equal 0. Now we have to look at the overall function. So in terms of, we want this whole thing to be greater than or equal, well, greater than 0. Can't have 0 in the denominator, right? So greater than 0. So when is that going to be positive? That's positive when x cubed plus 1 is greater than 0 and x is greater than 0. It's positive when x cubed plus 1 is less than 0 and x is less than 0. Okay, so this would be, so x cubed plus 1, you can factor it using a sum of cubes, but really if you think about x cubed is greater than negative 1, when is it equal to negative 1? When x is equal to negative 1. So this is going to be x greater than negative 1. And then where do these overlap? Here. Okay. Then here, this is going to be x less than negative 1 and x less than 0. So where do those overlap? Here. So this domain, this is the domain of the final. Where does that overlap with x can't be 0, which is basically everything except 0, is this. So the domain overall is x greater than 0, x less than negative, well, maybe I'll put order. Okay. Oh, there it is. Okay, so then determine f of x. Okay, so we have equals f of root of negative x, and then the root of negative x. So we know here that x would have to be less than or equal to 0, so that when we take the opposite sign of it, it becomes positive, radicand. This is saying that, so we're going to get a positive out here, okay, from this, changing the sign. So that means that the root of negative x has to be less than or equal to 0. So we have to basically solve this in our final composition. Square both sides. So then we get x greater than or equal to 0 when we solve that. Well, where do these overlap? Only at 0. So this is only defined for one value of 0. So that's kind of a tricky one. Okay, so that's it. Lots of composition. You'll end up going through composition again in Math 30, which is good because it's a tough one, but this is a good start to it.